What's going on, Alex Bros? It's Mr. C here, and in this video I'd like to discuss transformations on exponential functions. So the types of exponential functions that we're going to require doing some transformation work with are going to be of this format mostly. F of x equals a, which is the base, and in its exponent we're going to have the expression x minus h. And then back down on the ground, we're going to write plus k. Now, in the exponent, I have the expression x minus h, and I also have parentheses surrounded around it because this is where we're going to identify any horizontal shifting. Okay, so whatever is being added or subtracted to x is speaking to a horizontal shift in your graph. So I just want to note that any numbers here would indicate a horizontal shift, whereas any numbers that trail the exponential expression would indicate some sort of vertical shift. Now, it is possible that there are some reflections. In terms of transformations, we were discussing two types of reflections, one across the x-axis and one across the y-axis. And those would be indicated by any negatives in the exponential function. Specifically, if there's a negative in front of the exponential expression, this would indicate an x-axis reflection. Whereas if there are any negatives in front of the variable x in the power of a, that would indicate a y-axis reflection. So let's do an example. In example part 1, we have f of x equals 3 to the power of x plus 1. I'm going to put x plus 1 inside the grouping symbols since that makes up the exponent. And to start things out, we actually want to identify the base, which in this case the base is 3, which is a base value a that's larger than 1. So because this base is larger than 1, before any transformations take place, we would know that the graph starts out in the following way. There would be a y-intercept at 0, 1, and to the right of this point, we'd have an end of the graph going up to positive infinity, and then to the left of this point, we'd have an end of the graph approaching the horizontal asymptote, which for now is the x-axis. Right, and this would be your base graph or graph 1. There's only one transformation involved in the function provided to us, and that's indicated by this plus 1 that's in the exponent with x. Since we're adding 1 to x, recall that this is going to be a horizontal shift. Because we're adding 1 and we have to think opposite with horizontal shifts, this is going to require us to shift our graph left by 1 unit. So we're going to take graph 1 and shift it left by 1 unit. And to start that out, I'm actually going to take the y-intercept of 0, 1 and move that left by 1 unit. And then since this is the only transformation involved with the function, I'm going to redraw the shape of the graph like I have in graph 1 with its shifted version, as well as the horizontal asymptote. I'm going to fully connect this graph when I do so. So to the right of this point, it'll still go up to positive infinity, and to the left of this point, it'll still approach the x-axis, which is the horizontal asymptote. So the horizontal asymptote does shift left by 1 unit along with this graph, but if you shift a horizontal asymptote that's going along the x-axis to the left by 1 unit, you'll still end up with a horizontal asymptote going along the x-axis, which is why I'm drawing it in its same location. I will indicate that this blue graph right here is our final graph. And I also want to indicate where 0, 1 moved to. It moved to -1, 1. I'd also like to include some details regarding this function, namely the domain, which would be all real numbers, the range, which would be parentheses 0, comma, infinity, since this graph is entirely above the x-axis. The equation for the horizontal asymptote, which we have marked on the diagram, y equals 0. And then the new location of 0, 1, which was -1, comma 1 on our final graph. And there we have it, an example of graphing an exponential function using transformations. Of course, if you have any questions about this video or the content included in it, feel free to let me know. Otherwise, thanks for watching, and I will catch you guys in the next one. Goodbye.